G'day everyone, how you going? This video now is for the test that we did the other day. Hopefully my computer will do what I want it to do. There we go. So this is the test we did the other day on functions from this part of the course. Let's go through the answers and try and just isolate the things we didn't do so well. The first question here, this was really just taking our linear equations and finding x, y, intercepts and the gradient. I'd filled some already for you, so you kind of had a hint at where you were going. Most people were good with the first one, wasn't too bad. The second one, again, most were pretty good. The third one, it might be handy to rearrange this into y equals negative x, oh gee, this is not working for me. There we go. Into negative x plus 3. If you rearrange it, then you'll probably find that you see the gradient a little bit better, and you see the x-intercept and y-intercept a little bit better. Half a mark each one. If you got, say, 5 in the right, you would have only got 2 marks. I rounded it down to even marks. So half a mark each, rounded down if you made a mistake somewhere. This one here, and you'll notice on these questions, I think on all of them, I've left the, no, some I've left where I got it from, what the question was testing. So that's from our syllabus. Gradient of 2 passes through that point. Now, it did ask for it in this format, and you can put it straight into that format if you want. I find it easier to use the y equals mx plus c format, get the 2 and the 3 in, you can see they're in here, rearrange to get c. Therefore, I've got it in the mx plus c format. Quick little rearrangement. Either one of these would be okay. This second one is really just the first one with negative 1 multiplied through. Either would be fine, doesn't really matter. So 1 mark over here, 1 mark for the C value, because that was really the first thing you needed to find. Parallel lines. So as soon as we see parallel lines, we should be thinking this. The gradient of the first is equal to the gradient of the second. Because the question said the gradient was 2, therefore this second line that I'm getting is going to be a gradient of 2. So I got that in here, along with the point that it crossed over at, or it went through. And very similar to before, I can work out the C value here, and then put all that information together, I get my final answer, 2x plus 5. Most people were okay there, that was okay. Third line, perpendicular, well that's the next part on the dot point that we're talking about. So this is what you should be thinking. So therefore M2 is negative 1 over the gradient of the first one. So we look here, start with y equals mx plus c, put in my gradient in here, here's the negative 1 over 2. And then I substituted in the point, 2, 7, and it came through to c equals 8, and over here I wrote my final answer. If you want to write minus a half times x, you can, but this is probably a little bit neater, negative x over 2. Question number 3. The first part of this was pretty simple, but what people didn't realise is the scale of the y-axis and the scale of the x-axis were different. So it wasn't just going out a certain number of dashes. Obviously this is 2, this is 1, minus 1, but this is 1 here. So the scale on the vertical axis is, if you like, half the scale on the horizontal axis. So I did that purposely because I didn't want you to necessarily see where you were going in the second part just by seeing a square Cartesian grid. So that's where the points are. They're all above the x-axis, and why is that? Well, when we look at the y value, the second number, they're all positive, so that would say they're all above the x-axis. Some in the negative side compared to x, some in the positive. Now I paid follow-through marks below here wherever I could, where I could see what you were doing. A couple of different ways of finding this endpoint. I just looked at the change in the x values and the change in the y values between the 2 points that I know as an endpoint and a midpoint. So here was the change in those values, the x and y. So then I just applied those changes to the midpoint, the D, and I came up with 0, 8. Now when we look at the graph, that kind of makes sense, because you can see my little diagram here. Well, it's 1 here that I've moved that way, so I've got to move another 1 over. So I'm going to be on the y-axis. I've moved up 3 and I get to 5, so I've got to move up another 3. Kind of makes sense when you see it like that. Second one was midpoint. You've got the formula, it's on the formula sheet. Take the 2 points you need, get them in, do some number crunching, out we come. Most people should have done well there. Pretty easy questions really. They were on the syllabus, I mentioned them a couple of times. This question is asking you to find the point where they overlap or intersect. So really just take the y value, or the formula for the first one, formula for the second one, realise that when they cross over, the y values are going to be the same. So I end up with this quick little rearrangement: x is equal to 2. Take that, put it back into either one of them, doesn't matter. I did it to the first one, came out with -2. Therefore, there's my point. You can see where the marks are, showing me that you understood this concept, got you 1. An x and a y value got you 1, and because the question said determine the coordinate, I've got to answer as a coordinate. I can't just leave it as x equals y equals. These ones were testing that dot point that said about being able to manipulate and rearrange formulas to solve. So the first one here was just a linear equation, so I could just rearrange and solve. The second one, now that one, we had the squared in there, and quite a number of people forgot about this. So if I've got x squared equals 16, then when I take the square root of 16, there's a plus and a minus answer there. Because if I take the -4 squared still gets me to 16. So always remember, if you're taking the square root of a number to solve an equation, you've got to have a plus and a minus in there. This one just brought in a few fractions. A couple of different answers. I would have accepted 24 over 15. I didn't ask it to be simplified. 8 over 5 is the same. 1 and 3 over 5, either are good. The point of this question for me was, can you manipulate this fraction and get it to solve? Not so much how you answered it. So the answer wasn't real important. And the last one, and again, quite a simple one. Really, that's similar to the first one up here, but we've got x's on both sides, and the syllabus does mention about that, to solve equations with unknowns on both sides. So that's why I put that one in, because it tests that ability to move all your x's to one side, all your numbers to the other side, and then solve as you need to. So that was part 1, or part A, without a calculator or your notes. We then get on to part B, which was a little bit longer in time and marks. So now we've got our calculator, and I did all of this without my calculator, but I'm going to show you where you could have used your calculator to be a little bit quicker. This question here, you couldn't really use your calculator. You might have an e-activity that will do this for you, but that wasn't the intention. The intention was for those students who thought they could do everything on the calculator. It was a bit of a time waster. All I would do is just do your normal completing the square, half this and square it, add it on, take it off, bracket up this part here, put it into the square format, put the -7 on the end. So that was part A of this, or the first part of this question. But notice here it said, and hence state the equation of the line of symmetry. So we get the line of symmetry from the variable in here. That's how it moves at left and right. In this case, it's moving at 2 to the left. So we needed to write our line of symmetry as x equals -2. Now, it's a key point to remember. It's asking for the equation of the line of symmetry, so it's got to be x equal. It's not equal to -2. It's not just -2. It's x equals -2. All right, it did ask for the equation of the line of symmetry. This next one here, this is about the discriminant in the quadratic formula. Now remember, if the discriminant is positive, we get 2x intercepts. If the discriminant is 0, we get 1. If the discriminant is negative, in our course at the moment, we get no solution. In mathematics, you can get non-real solutions, and we'll do that later on. Those spec people will do a bit of work in that as well. But for us at the moment, this one gave us a -36, no real solution. A +49, 2 real solutions. Now, if you didn't put real solutions in, I'm not worried about that. 1 mark for your number crunching, 1 mark for your interpreting the answer. This one, now this is where you could have done a bit more work in your calculator and done a little bit handy with the calculator, but it said use the quadratic formula. So if you just shortcut came right down to here out of your calculator, then you wouldn't have got many marks. I would have given you probably 2 marks, not the 3, because I wanted to see that you could use it. But that doesn't mean you couldn't put this on your calculator, solve it, know what the answers are already, and then you just make your mathematics fit to kind of make sure I'm happy that I've seen you do the quadratic formula. So could you do all this on your calculator, come straight here? No, but you could certainly use your calculator to check that you've got the right thing going on. Finding the turning point of that equation. Now this is where your calculator would have been an advantage. You could have just had that formula straight in graph and table and gone analysis, G-solve, turning point, or you would have got it, or sorry, minimum, maximum. you would have got it. You could have also solved this equaling 0. Actually, no, you couldn't do that. No, you'd need to find the turning point, but the turning point would be halfway between these two. So you could have done that, just got the 3.5, put it straight in the equation like I have here, but on your calculator, and got that, and again, got your turning point over here. All right. So a couple of ways you could do it. Calculator could speed you up a little bit there. This next question is a really good question. This one came from an exam paper a couple of years ago, and I've seen it in many different guises as well. Basically, we're giving you 5 quadratic or parabolas, and you need to determine the equations for them. Now, I'll try and get this all on one screen, if I can. There we go. All right, let's just work with that at the moment. So notice I went along and I actually put which equation was relating to which formula. Now, there's quite a skill in picking this before you even look at the values down below. I chose this one to be equation 2, or parabola 2. That's this one here. Now, the reason I thought that was going to be there is that this one hasn't moved left and right. It's still, the line of symmetry is still on the y-axis. So it shouldn't have anything like this, or this, or this. So really it kind of refines it down to maybe that, maybe that one, or this one. Now this one here is going to have 2 x-intercepts, right? This one is going to have no x-intercepts. So I reckon that one. So that's why I put a 2 there. And it kind of looks, yes, it's moved up. I don't know how much, but it's certainly moved up. So that kind of fits there. This equation here is not got a different shape. It's not moved up or down. It's moved 7 units to the right. So the only one that's moved just to the right is this one here. These have moved up and right, up and left, down and left. So this one, I'm pretty sure has to be that. Now I'm going to look at these two at the same time. They're both negative, so I'm pretty sure it's going to be this one and this one. They both have a plus value on them, but this is bigger. So I'm kind of leaning towards that one being there, and that one being this one. But let's check the last part. This has got a +1 in here, so it's moved 1 unit to the left. Well, that kind of fits this one, doesn't it? Line of symmetry would be about here. This one's a +2 moved to the right, so that kind of fits this one. So I reckon 5's over here, and I reckon 4 is here. Now, of course, that only leaves 1, which is this guy over here. Let's just check him out. Positive out front, so it's up this way, good. It's got 2 x-intercepts, good. And the x-intercepts are both negative, -5 and -9. That seems to fit. So there's quite a skill in just getting that part sorted. Once you've got that sorted, the rest is not so bad because you know what you're looking for. Now you'll notice here I changed this one over because have a look at this. Graph 1, which is this one, has a x-intercepts of -a, -b, right? So -a, -b. So the value out of here would have been -5. But notice we've already accounted for the negative. So therefore the value of A is just 5, the value of B is just 9. But then it says the value of A must be greater than B, so I've actually got to swap them around, 9 and 5. Quite a lot of thinking in there, happy to go through that one again, but you've got to look at what do I get out from the equation as my intercept, what have I already accounted for here, that is the negative, and then do I satisfy all of the constraints, and I didn't when I pulled that first out, I had to swap them over. Hence you can see I've swapped them over there. The rest weren't so bad. I think most of the others, once you have another look through, you'll get them. 1 mark for each of them. Unfortunately, there's no half marks or anything like that. No follow through. You either got them or you didn't. A few people left a few ones blank. Look, if you leave them blank, you're not going to get the marks, of course. Have a guess. You never know. You might get one of them. They'll normally be whole numbers, fairly logical whole numbers. You know, don't guess 312, but, you know, between 0 and 5 or 6 is going to be a pretty reasonable guess. Doing your probabilities, you've got about a 1 in 6 chance of getting it. Question number 8. This one I actually took from a Victorian exam. I can't remember what year it was, but a number of years ago. I changed it because I've got a few names in here. I think I've got Taj and I think I've got Georgia down further. So this question here, this is a really important one for a bit of thinking around here. It asked you to show that M is 28.35. Now over here, this is what a lot of people did. They said, oh look, if I put that into that, 567 equals 567. There we go, job done. No, this is meaningless. 3 equals 3, 2 equals 2, 5.75 equals 5.75. That doesn't show or prove anything, right? What you need to do is basically just work the gradient out. So I'm saying that M is equal to the gradient, and from the numbers above, up here, I picked up that I've got a point there. Now you can either see that this is 567 divided by 20, or it's the rise divided by the run. And that would come out the same because the zero part of it wouldn't make any difference. So I've got to show what I'm doing, not just write 567 equals 567. Taj found a decent sized nugget. Well, the multiplication factor is that's just the formula above. It is asking about the weight of, so grams on the end. I didn't penalise anyone for missing the grams, but please don't forget that. The second part here is that Georgia sold quite a lot of gold, $12,500 worth. Well, at $55 a gram, by dividing by 55 tells me the amount of grams that she must have sold. And the question asked for ounces. Because of my formula above, I've got to divide, came out neatly to 8 ounces. So it was quite a neat one there. Now the last question, this one was a really good question. Really, really good question. I intended it to be a little bit difficult as well. We've got it in this format, and we know that it passes through a point, and it passes the x-axis at these points here. So y value is going to be equal to 0. Now, remember you've got 3 different forms of your quadratic. You might think, well, I'll start with this form, but actually that won't get you far. You actually want to start with this form, the intercept form, because I've got the intercepts and I've got a point. So that means I can put my intercepts into the B and the C. Remember, as I put them in, I've got to swap the signs. And I can put this point in for the X and the Y, meaning the only thing I don't know in there is the A. So I can solve for A, get a quarter, put it back into what I started with the x-intercepts in there, expand it out, and I end up with that one there. So therefore then my A, B and C value I can read straight out. So really that format of the general format, I only used that right at the end. The rest of it was all done in intercept format. So a neat little question there. Again, these last two, a bit tough. State the value, state the location of the y-intercept when that happens. If we're multiplying it by -5, the negative is flipping it upside down and the 5 is stretching it out. So in fact, I just take what the value of f of 0 was and multiply it by -5. Now I probably should have, it was only worth 1 mark. It said state the location of. Look, I could probably say I probably shouldn't have given myself a mark here. The location really, being a y-intercept, would be 0, 50. Because a coordinate would be the location. But look, if you got the 50, I gave you the mark. I wasn't going to be worried about that. Now the last one, because it's inside the bracket, what happens inside the bracket is stretching the graph or squashing the graph. When we've got a 2x or a 2 in there, it's actually squashing it up. So there's two ways of thinking. Think that it squashes the graph up, so take my x-intercepts and halve them. That will work. But here's a better way of thinking about it. If you had f of 5, you'd take 5 and put it into the equation. F of 3, put 3 in. F of 2x, put 2x in. So remember, this will become 4x squared. The 4's will cancel. This becomes 6x over 4 or 3x over 2. And the 10's not changed. Okay? Now this is a bit tricky to factorise, I will agree. This is what works. 4 and 2.5 will mean I'll get my -10. So because of that, I can do this, and then I read those numbers out, and I get these ones here, exactly the same as what I saw by squashing the graph up. This was a bit tough for people to get, and I understand that last question. If you got only 1 or 2 marks out of the last question, you're doing well. I don't think anyone got full marks on the last question. So it's just a tough one to really separate those people at the top in their thinking. But the rest was fairly achievable, and there's been some really good results from it, so I'm happy about that. Hope this has helped. Please review this test and your exam will have similar questions to it. So good exam practice here. Thanks very much. See you later.
Like and subscribe.